dealing with the science of the earth, a Russian document translated into English, and you go through that document and you see where it's highlighted there in red that the shape of the earth is not known in 1948. Great video out there Pastor Dean Odle did on a whole bunch of NASA documents. He goes to CIA declassified documents showing consistently them saying, well, all of our math for the high performance aircraft that we're using is done based on a non-rotating flat earth.
I had to leave a lot out this morning. I understand that this is just the tip of the iceberg. Now, notice it says outer gravitational field and shape of the physical surface of the earth. All right, you can go through this entire document if you want to. I'm just pulling out something that I found very interesting in 1948 from Russian scientists that was classified. They stated here that where it is not determined at all of the points of space without the knowledge of the shape of the earth, but since the shape of the earth is not known. I just wanted you to see that a Russian scientific paper that was classified in 1948 states the shape of the earth is not known. Now let me remind you that we are always told, oh, we've known the shape of the earth since 300 BC. Here's another document. We move forward in time a little bit, 1956, 57 time period. What happened between about 1948 and this time? The development of jet aircraft and the increase in rocket technology. So we were beginning to be able to fly a little higher, a little faster. Here we go, October 1953. This document was not to be seen. Here, now I want to point this out. Present equations hold for any altitude. Everybody see that? Table of contents, introduction, validity of flat earth assumption for atmospheric calculation. You know what validity means? Something that is a solid fact. If the earth was not flat, why would you classify that? Introduction here says a comprehensive study of atmospheric refraction errors for optical instrumentation. What is it based on? Based on a flat earth assumption, will be published subsequently. This relationship is correct for a flat earth and a flat atmosphere. See, this is what some of them say, that the flat earth assumption is just to simplify that. But what this is saying is this so-called flat earth assumption is valid. The definition of validity, the quality of being logically or factually sound. Look at that. Here's more of it here. Academy of Sciences, USSR, Astrophysical Institute. We're not fooling around here. Here's all these PhDs and scientists that are involved in this. Tells you a little more of the introduction, the table of contents. All right, it said the observations were carried out in 12 locations at various altitudes above the sea, various climate, meteorological, synoptic conditions. The observations were carried out mainly during high transparency of the atmosphere and the visual range of the spectrum, the absence of snow cover, and the investigations. 2 instruments designed by V.G. Fescanoff or whatever were used. One of these was a visual photometer of the daytime sky intended for measuring the brightness of the firmament. They were wanting to study this, and they said also the other photoelectric halo photometer for determining the brightness from near sun halo. Whoa. Pause, time out. How is something that's supposed to be 93 million miles away, could anything about it be called near? But it gets better. He says that to study the near sun halo and also the sun on the surface perpendicular to these rays. The dissertation contains a certain formula of the brightness of the sky, taking into consideration only the brightness of the first order, derived on the assumption of a flat earth. Remember, they're trying to study how light is operating within the atmosphere with a near sun halo, and they tell you over flat earth. This is a Russian document, 1957. It was classified. This is a secret, eyes only, Central Intelligence Agency declassified 2006. But this document makes this statement at the end. The shape of the firmament, do you see that? Whoa, hold up now. I think only certain solid things have shape, right? The shape of the firmament. Does everybody see that? Do you see that? What is a classified document? classified by the United States government, talking about the shape of the firmament. How does an atmosphere, invisible vapor, how does it have a shape? But they're talking about, we got to figure out the shape of the firmament. Just like one of the Russian documents talked about, they were measuring the brightness of the firmament. They used that term, the brightness of the firmament over a flat earth. The Russians were talking about this back then. All right, now let's keep going. April 1961, National Aeronautics and Space Administration, calculation of wind compensation for launching unguided rockets. Rocket science, calculating wind. Pretty important thing to know. Summary, here's what we're up to. The missile position in space is computed relative to a flat, non-rotating Earth. April 1961, NASA technical document for calculating unguided missiles, not anything we're sending into space. Unguided missiles like the V2. Here's another one. Okay, completely different document. Engineering Experiment Station, Georgia, Institute of Technology, Atlanta, Georgia. A model frequently used, flat, unrotating Earth. The most one can profitably simplify the problem is to consider the isothermal atmosphere, plane level surfaces, and a non-rotating Earth. Here, everybody see this? NASA technical memorandum. Where'd it come from? NASA.gov, right? Let's keep going here. This is a summary of it. Here's what they say. The method is limited, however, to application where a flat, non-rotating Earth may be assumed. To say that the method is limited to a flat, non-rotating Earth means it does not work for a spherical Earth. This is interesting because he talks about, it gives you this little frame reference. Look at north, south, east, west, right? And they're telling you that, again, that represents the Earth fixed axis system. Everybody see that, right there? The radar provides range, azimuth, and elevation data from radar site to the vehicle throughout flight. So we're talking about stuff happening throughout flight, right? The data in conjunction with wind data can be easily converted to pitch, blah, 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 flight path angles. It is assumed herein that the Earth is represented as a flat and non-rotating reference frame. Why would it be assumed that the Earth is represented as a flat, non-rotating reference frame? I'm going to tell you, I'm blown away, but this Earth fixed system is interesting here. Isn't it supposed to be spinning, tilted, orbiting, flying through the universe? Yet the stars never change in the sky, right? The night sky. But yet we're spinning, flying, orbiting, millions of miles. Nothing in the night sky ever changes. They know. Come on, they know. It is assumed herein that the Earth is represented as a flat, non-rotating reference frame. Yet they're going to tell us snipers have to adjust for shooting a 1,000-yard shot. It takes about 2 seconds, maybe less than that. But you don't have to calculate the Earth's spin for an aircraft, for a helicopter, a drone, the space shuttle. I'll show you that in a minute too. Let's keep going. Here it is. Notice it says, also by definition, the X and Z plane will be vertical, perpendicular to the horizontal plane of the Earth at all times. What's this one? This is NASA Technical Memorandum, NASA.gov, mathematical model of a CH-53 helicopter. Equations of motion. The helicopter equations of motion are given in body axes with respect to a flat, non-rotating Earth. Meaning the helicopter takes off, it doesn't have to worry about the Earth spinning below it. You can look it up. Anybody out there watching and listening this morning, you can Google NASA document 1207. You can pull up, it'll take you straight to nasa.gov. You can pull up the PDF. You can read this for yourself. This is free information. The derivation and definition of a linear aircraft model. In the introduction, they flat out say right here, this report documents the derivation, which means the origin, and the definition of linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. Derivation means the origin. Definition means this is how it's defined. This is how it works. So they're talking about the equations. The equations are based on these airplanes flying over a non-rotating flat Earth. Why would this be in any technical manual of anybody if it doesn't exist? I mean, think about it. They claim the Coriolis effect, that snipers have to calculate the spinning of the Earth, the Coriolis effect, when they're shooting at, 1,000-yard shot or something. Yet they don't have to for Mach 1, 2, 3, 4 aircraft. You don't have to calculate the spin. No. Oh, well, they're just doing that to simplify the equations. Oh, really? I'm sorry. I didn't know that NASA rocket scientists and MIT mathematicians couldn't factor in 8 inches per mile squared. I'm sorry, they have to simplify the math. Maybe they missed a class at MIT or something. I don't know. But this is crazy. Now you can try to dismiss this if you want to, but it's also in the concluding remarks of the report and all the math and the equations. Look at that. This report derives and defines a set linearized system matrices for rigid aircraft of constant mass flying in a stationary atmosphere over a flat, non-rotating Earth. I didn't write that. It seems that someone at NASA is a flat earther. How can this be? There's your definition of derivation. Obtaining or developing something from a source of origin. Why would you develop the equations for aircraft to fly over something that doesn't exist? Now they have to design stuff for it to work the way things are. Definition, of course, is a statement of the exact meaning of something. Let's keep going here. And what's interesting about this, and of course he goes, these models are widely used not only for computer applications, but also for quick approximations and desk calculations, leaving out Earth curvature and rotation for simplification. So again, I covered that. They're going to claim that it's to simplify their math and equations and their work. So they do it real quick on the desk, but I looked up approximation, and approximation means not really correct. So anyway, they write a lot of stuff that's not really correct. But I wanted to address the issue of cherry picking. Of course, the same thing said here pretty much. And let's just deal with this. Here we have an orange tree with cherries on it. I said, some people have accused me of cherry picking through the government documents that state their equations are based on a flat, non-rotating Earth. But should there be any flat Earth cherries to pick at all? But they tell me that the cherries are on the orange tree to simplify the orange tree math, thus I should ignore the cherries. I just wanted to illustrate that, of course, and there's your globe Earth tree with flat Earth cherries on it to pick, okay? If it's not flat, why address that? And some of them tried to say, well, okay, it was because of just for short distances. Well, I don't see the shuttle landing over short distance. I don't see Mach 1, 2, 3, and Mach 4 aircraft like the SR-71. I don't see it being short distances that it covers in very, very short amount of time. So what I'm getting at is the reason that so many different government documents, technical manuals, MIT, different universities, Georgia Tech we addressed, use these flat Earth equations is because it is flat. And they know it, and they've known it for a long time, and they have to design things to work as reality is. Army Manual, February 2001. You can say, oh, Pastor Dean, the 1950s stuff and the 1960s stuff, oh, they just didn't know. They've learned stuff since, right? Nope. They tell you right here. And you go into the manual, here's the table of context. It says comparison of principal fields from an ideal dipole oriented perpendicular to a horizontal and homogeneous flat Earth. They tell you right here, it's assumed that the transmitting antenna and target or receiver are located above but near the surface of a flat idealized Earth. Army Research Laboratory. This is another one, calculating low atmosphere profiles, sound speed at night. So calculating sound speed. It says to briefly examine short-range acoustic attenuation at night, we use low atmosphere profiles of wind speed, temperature, relative humidity shown before as input to a flat Earth non-turbulent acoustic propagation model called the Windows version scanning fast field program. So, you know what they tell us? That the atmosphere is not moving with the spin of the earth. It's non-turbulent. I mean, it's not carrying anything with it. Here's MIT, Massachusetts Institute of Technology, the top technical school in the country, dspace.mit.edu. And then in the description, it says 3 targeting methods were considered assuming a flat earth. Whoa. Why would an MIT professor, PhD, would he assume the earth is flat? Mind-blowing. Just wanted you to see MIT and other doctoral candidates and PhDs saying it's flat and it's not moving. That's what the Bible said. It's flat, it's not moving. If I say it, I'm crazy. But these guys can say it, and their papers get passed around among the elite, and a lot of them classified. Yes, and many of them do have Nobel Prize, and they get sometimes they get classified and then declassified. Here's one. This one is NASA.gov. Now this is general equations of motion for a damaged asymmetric aircraft. So what they're trying to do is fix equations if a plane loses part of its wing or tail fin or whatever, how to compensate and all that stuff, right? So that's what this is about. And the technical manual gives you this stuff. The introduction, here's the introduction. It says, in order to analyze the dynamics of damaged aircraft, the dynamic equations of motion must properly reflect the underlying physics. They're telling you right here in the introduction of this, what we're gonna do here must reflect the true physics. Who are we talking about here? The American Institute of Aeronautics, Astronautics. In this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed. Why? You're telling me that the physics of a non-rotating flat Earth are the proper physics. These are NASA documents. These are government documents. Now, here's a doctoral dissertation by a PhD candidate that became part of this European Control Conference. A new path planner based on flatness approach, application to an atmosphere reentry mission. This was designed for the space shuttle, quote, reentry. And it's funny, they put orbit and reentry and stuff like that into quotations. And I'll explain all that next week. We'll get into that next week. But notice the outline of his doctoral dissertation. Statement of guidance problem. Why would you have a guidance problem? Well, if you're basing stuff on a spherical Earth and it's really flat, then you're gonna have a guidance problem. So this guy comes along and goes, you know what? We gotta get back to a flatness approach. He's talking about for this little vehicle right here. Notice he says model in flat Earth coordinates. This doesn't exist, right? Flat Earth doesn't exist, but we're gonna have a model for it and all this unicorn math. So this guy's doing a doctoral dissertation in this present time to help with guidance system of the shuttle. We've had guidance problems, so we gotta go to a flatness approach, to a flat Earth model. Now, I'm gonna tell you, this guy's way smarter than me. I couldn't do this kind of math, not even in my dreams, but he does. And he says, guys, we need a flat Earth model. And here's the math for it. Shall we keep going? Notice this, assumptions, meaning things we assume are true. Flat Earth, Coriolis and centrifugal forces neglected. Here's a doctoral candidate who graduated, got his PhD, becomes a speaker to the European Control Council, and he's telling them it's a flat Earth. We ignore Coriolis, meaning the spin of the Earth. It's completely ignored. Oh, payloads for spinning projectile. Army. Think you need to know where artillery is going to land? Projectile flight dynamics. A 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. The assumption of these equations assume a flat Earth. These equations, a whole bunch of math we're going to do. And again, a projectile, you want to know where that artillery round is going to land. And what this study is, the one that has a solid explosive versus one that has a liquid payload. So they want to know, figure out the equations. So a 6 DOF rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. Again, why would you do unicorn math? Why would you do Thor hammer math if they don't exist? Why would you try to calculate ballistic missiles, unguided rockets? Why would you base all your equations, all of your science on a flat Earth, non-rotating, non-moving, stationary atmosphere if it doesn't exist no more than a unicorn or Thor's hammer? This is the Army Research Laboratory. Notice every time when you see .mil, whenever you see .mil, in the United States, the only people that can have .mil, military. This is the Army's Research Laboratory. Beacon position and altitude navigation aided by magnetometer. You can see the document prepared by the University of Delaware, Department of Electrical and Computer Engineering, under contract to the U.S. government, PhDs and the people who were assisting this study. And here we find something. Problem formulation, coordinate systems. The motion of an object usually described by rigid body equations of motion derived from Newton's laws. This section summarizes and notates three kinds of coordinate systems. The first is the Earth-fixed coordinate system, which is fixed to the Earth with a flat Earth assumption. It gets more interesting because they have a little diagram here of what they're talking about. And this little diagram of the Earth seems to look like something. And they tell you that this y-axis and the x-axis are horizontal. Oh, like that. Horizontal. And that this little disc right here is flat. And it even has a nice little dome over it. And fixed points on the dome that they use for navigation. Here we go. NASA.gov. You could interchange CIA.gov, NASA.gov, it's all the same. Here we have the singular arc time optimal climb trajectory of aircraft in a two-dimensional wind field. So this document goes on to say, in our minimum time to climb problem, the aircraft is modeled as a point mass and the flight trajectory is strictly confined in a vertical plane on a non-rotating flat Earth. Let's keep going. Here's another one. Closed form solution for ballistic vehicle motion. Ballistic vehicle motion. A closed form solution is developed for the motion of a ballistic vehicle entering the atmosphere over a flat, non-rotating Earth. Frank J. Barbera, Cayman Sciences Corporation, Colorado Springs, Colorado. Here's another one, vision-based mobile target geolocalization and target discrimination using Bayes detection theory. And this is for targeting for unmanned vehicles, aerial vehicles, targeting. Here we go, check it out here. The objective of geolocalization problem is to estimate range to target, which can be estimated using the flat Earth model shown in figure 2. So we're talking about here unmanned aerial vehicles targeting objects. Stuff that's moving in the air and on the ground. And what do they say? It says the objective of geolocalization problem is to estimate range to target, which can be estimated using the flat Earth model shown in figure 2, which would be this little thing right here. Range estimation using flat Earth assumption. Unmanned vehicle targeting manual from the United States Air Force Academy.